Hello, this is Mr. Huber. In this lesson, we're going to look at rational exponents. You're familiar with the word rational and exponents. Exponents, right, is something we raise as a power for some number or expression. And rational, if you recall, means something can be written in the form a over b. When we talk about rational numbers, they can be written as a fraction. So now we're going to see exponents that are fractions possibly, or they could even have decimals in them. And these properties over here on the left side are no different than the properties you're familiar with already for exponents. Okay? When we multiply like bases, we add the exponents. And you can see examples of that over here where the exponents are fractions. So 5 to the 1/2 times 5 to the 3/2, we add the 1/2 and 3/2 together. That gives us 2, 4/2, which is 2, 5 to the second power. When you have a power to a power, you can multiply them. Again, these properties down here are given with examples where the exponents are fractions. Let's look at one a little bit in particular here. This 36 to the negative 1/2. Recall a negative exponent means we write it as a reciprocal. Okay? So here we'd put this as 1 over 36 to the 1/2 power. Well, then how does that 1/2 power make the 36 to a 6? We're going to talk about that a little bit here and how we can work with rational exponents as radical expressions. So here we see x to the 1/2 is a number whose square is x. That means x to the 1/2 is the same as the square root of x. 1/2 power is the same as a square root. 1/3 power is the same as a third root. 1/4 power is a fourth root, and so on. And we can use that where it's not only a 1 in the numerator. Anytime you have a rational exponent, the denominator will be the root. Whatever's on the bottom of the fraction in the exponent will be the root, and the numerator will be the exponent. Okay? So that's why we see x to the 1/2 is a square root to the first power. We don't have to write the first power. Or x to the 1/4 is a fourth root to the first power. Again, we don't have to write the first power. But if this m is anything other than a 1, we can write it as an exponent to whatever that nth root is. Let's see some examples of what that looks like in actual numbers. So here we're just going to write these expressions either as rational exponents or radical notations. So we're going to go back and forth and be able to write both of them. In this first example, we're given a radical expression. We have 10 to the 7th root, okay, or the 7th root of 10, however you want to read that. So when we go to write this as a rational exponent, it's going to be 10 to the 1/7 power. Right? There's a 1 there that we don't have to write, the first power. We don't have to write it, but it's there, and that's the numerator then in our rational exponent. In example number 2, we have 8, and our rational exponent is going to have a 4 as the denominator, right? Whatever our root is the denominator of our rational exponent, and the numerator is going to be whatever that power is, so in this case a 3. So these are equivalent expressions to each other. The fourth root of 8 raised to the third power is the same as saying 8 to the 3/4 power. If we come down here, we have rational exponents we want to now write as radicals. So 9 to the 2/5 power. And this 5 is going to be the root, and the 2 is going to be the power. So we have the 5th root of 9 to the 2nd power. We could also write this as the 5th root of 9, and the 2nd power could be inside the radical along with the 9. It's the same thing. Over here we have 15 to the 1/3 power, so that's the 3rd root of 15. Since it's to the first power, we don't have to write the power of 1. You can, it's not wrong, but you don't need to. A little break here. Social interlude, social security numbers. You have a social security number. If you don't know it, you probably should know it. Down the road, it's going to be something you use quite often in identifying yourself on particular documents, and in college you'll need it, and then beyond. So your social security number is important. It helps identify you. It's one of your primary pieces of really secure private information you should have. And there's an example in there: 1, 2, 3, 4, 5, 6, 7, 8, 9. They're broken up that way. We're 3 digits, 2 digits, 4 digits. And those numbers do have some significance, or at least they did. In 2007, the Social Security Administration stopped these numbers having significant meaning, but your Social Security number would have meaning in terms of those numbers. The first three numbers are called the area numbers of your Social Security number. They were assigned based on the area where you applied for a Social Security number. So these first three numbers here will be similar to someone else who's born in the same area as you, because typically you're going to apply for Social Security number the same around the area where you were born. Okay? And they would start with the lowest numbers in the northeast of the country, in the New England area, and then work their way out west. So the further to the east in the country, typically those numbers would be lower, up through higher three-digit numbers over on the west coast and beyond there. And again, people in the same area will typically have those first three digits being the same. The second two numbers are called the group number. Those were assigned somewhat randomly, odd and even numbers, just progressing their way up from lower numbers to higher numbers, and then going back and filling in. So there's no real significance necessarily, other than Social Security Administration just would randomly assign them, and they would progress their way up. And the last four digits you see there are called the serial number. Those would follow a strict numerical pattern in the order, and they would just assign them as numbers got higher. You'd get a higher and higher number as they assign more and more serial numbers. Again, you can make a lot of combinations here with the different group numbers and serial numbers. So after they filled in the group number, they would get a serial number. They would then progress up till they filled them all in. Then they'd go to the next group number and then progress in the serial numbers and so on. So the ones that really have some significance, and you might want to check this out, you could find, see your other relatives, siblings, mom and dad, if they were born in the same area. Your first three digits of the Social Security number might be exactly the same, or at least close. Okay, so something you might want to check out, and it's interesting to note there is a little significance behind it, and not just complete random association. Again, now since 2007, it is more random. All right, back to rational expressions and radical notations. So now we're going to actually evaluate these expressions. So we're not just going to write them as radicals, but we're going to come up with what the value of these expressions is. So 49 to the 1/2, it would help to think of these as radicals, because then you're going to be able to simplify them and go from there. So these first one, 49 to the 1/2 power, we know that's the square root of 49, which would be 7. So that'd be the value of 49 to the 1/2 power would be 7. 81 to the 3/4. So that's going to be the fourth root of 81 cubed. So here we can take the fourth root of 81. The fourth root of 81 would be 3. 3 times itself 4 times. And then to the third power. So that's going to be 3 times 3 times 3, which comes out to 27. 4 to the negative 3/2 power. So we have to remember that negative means it's going to be 1 over the square root of 4 to the third power. That negative exponent here, remember we have a negative exponent, we write it as a reciprocal. So we take that expression, 4, the second root, and then third power will now be in the denominator of that fraction. And now we know the square root of 4 is 2, so this is 1 over 2 cubed, which is 1 over 8. So we get a fraction 1 over 8. Got a few more examples. Again, try some of these out, see if you're picking up on it, and you'll have an idea if you're on the right track or not, understanding these different types of rational exponents. Again, rational means a fraction for an exponent. 9 to the 5/2 power. So that's going to be the square root of 9. We don't have to write the 2 for the root. You can if you want to. And then to the 5th power. So that's going to be 3 to the 5th power. 3 to the 5th power. So 3 to the 4th power we saw on the previous page was 81. That'd be 3 to the 4th power was 81. So 3 to the 5th would be 81 times another 3. So that comes out to 243. Okay, that might not be one you know off the top of your head, but you can multiply 3 times itself 5 different times and get 243. This next one's a little interesting, 16 to the 1.5. So, right, rational exponents means it can be written as a fraction. It doesn't have to be. So 1/5 power we'd want to recognize as the fraction 3/2, 1.5. So this now is the square root of 16 to the third power. So that's 4 to the third power. 4 to the third power would be 4 times 4, which is 16, times 4 again, which is 64. So 64 would be our value for that. And we're finding actual values here by using these rational exponents in radical notation. 17 to the 1/2 times 17 to the 1/2 is 17 to the, or we can add, since the bases are the same, since we have a base of 17 and another base of 17, we add the exponents, 1/2 and 1/2. So now we can add those, and 1/2 plus 1/2 is 1, so this is 17 to the first power. We don't have to write the first power, it's just 17. So know how to work with some of these different situations with radical expressions based on the rational exponents, okay? Rational exponents, fractions, or a decimal that we can write as a fraction, and know how to use the denominator as the root and the numerator as the exponent.